Good evening, everyone. My name is Christelle Crozard, and I'm extremely glad to see so many people as you are here tonight for the first session of the Brussels Science Apéro. So thank you for coming. The initiative is organized by Minerva, which is a communication agency based in Brussels and specialized in science communication. Before starting the session, I would like to ask a few questions to Inano Spreafico, who is the director of Minerva Consulting and Communication. So, Inano, good evening.
Good evening to everyone, and thank you as well for coming here.
I would like to ask you, why are we here tonight together, and why this idea of the creation of Science Apéro?
Yes, so the Science Apéro, Brussels Science Apéro, is a new initiative that together with my team at Minerva we decided to launch as a way to share with all of you our passion for science. We would like to bring outside the laboratories, the science. We would like to bring scientists outside the lab and share with all of you, with the public at large, their knowledge and their experience. So we are launching the Brussels Science Apéro this evening. There will be one session per month on different topics. We are going to discuss about topics dealing with everyday life in a common language. And every time we will invite one or two experts, like this evening. And you're all welcome to ask for questions to all our experts about about any questions that you may have, any ideas and any curiosity, because the session is here for all of us, and we would like to answer all your questions.
So you mean expert? Do you think it's these handsome men who are the experts?
Well, the topic of this evening is aviation, so we choose two experts in aviation to answer all our questions. And this evening we have one aeronautics engineer, Andrea Nemetz, and we have one pilot, Jean-Philippe Delay. And they're going here to discuss about to share their experience and to discuss about aviation.
I would like to know, Inano, because maybe, probably some people among you noticed that my English is very bad. So probably I can imagine some people don't speak very, very good English to ask questions. So is it possible to ask questions in other languages tonight?
Yes, well, I would say English could be questions could be asked in English, in French, in Dutch, because we cover also Dutch. As Minerva, we are a multinational team, so you are welcome also to ask questions in other languages, because we cover pretty much all Europe. We have colleagues from the UK, from Turkey, from Romania, from Slovenia, from Lithuania, from all over Europe. So, well, we can understand pretty much every language, but the speakers of this evening can cover for sure English, French and Dutch, so I would ask
so it's not a breaking to ask question. So first I would like to introduce Andrea Nemetz, who comes from Italy, that's correct? And I would like to know who you are exactly, and could you explain a little bit more about you for everybody?
Good evening, everybody. As she just mentioned, as a background, I'm an aeronautical engineer. I'm dealing with aviation safety, so keeping an eye on what's happening in Europe and regulations that affects the aviation, and in particular business aviation. And in the past I've been working on different projects at the international level on air traffic management. I'm happy to reply as much as possible to all your questions, so again, happy to be here tonight.
Thank you, Andrea.
And we have also Jean-Philippe Delay.
Thank you. Welcome everybody. First of all, to relate to what Nando said, taking the scientist out of the laboratory, not a scientist, and the view out of my office at the moment is second to none, I have to say. So my background is mostly military. I was fighter pilot. Studied I got a master in aeronautics in military academy in Brussels. Most of my career flying fast jets and also transport aircraft. And for the last couple of years, I've been also I got my ATPL, which is the airline transport pilot license, and I'm flying now for a couple of years for a business aviation company. It's basically like a normal conventional airliner, but a small airliner with something like between 1 and 5, 6, 7, 8 passengers who choose to fly from A to B instead of taking a, and they probably have the financial means to afford that, of course. Just wanted to say that although we have some sort of scientific background, of course we had to study a little bit of aeronautics, aerodynamics and all those topics. We're not scientifics as such. I mean, we understand what we are doing, although when we don't have the answer to the question, we know where to look for the answer. And that's the most important part. I just want to reassure you, it's quite safe to fly, to be in aviation, especially in Europe, compared to other parts of the world. We are and that's why Andrea is working in flight safety, and aviation safety is even global, more than flight, but aviation safety as a whole. We know that 75% pretty much of all related accidents are human related. Not only pilots, but could be air traffic controller, could be maintenance people, and there is a lot of effort on safety. That's why we are in the cockpit. We are human beings. We can make mistakes, and we do mistakes quite regularly. Luckily, not big ones. And if it's a big one, that's why we have somebody next to us tell us, oh, by the way, you did that. Are you sure? No, you're right. So we'll try our best. And also I wanted to mention, I'm in no way talking to the Belgian defense or my present company. I'm just here as an individual. I've been invited by friends, and I found it's a very good initiative that Minerva started, because myself, I'm also interested in scientific subjects like medicine, and I would know a bit more. I would like to know a bit more, and it's very important to try and make it accessible to a lot of people, because there is a tendency to have a split in between the common human body and the scientific world. So it's quite a good initiative. So thank you for that.
And you, Andrea, what did you motivate to come tonight with us? What's your motivation?
Yeah, well, when I heard about this event, I immediately was keen to share my experiences, because Jean-Philippe said the aviation world is quite huge, and we can't know anything about everything, but we are here to share our experiences, and of course to make aviation safer, and this is our mission. So sometimes it's a bit mystery what's happening behind the cockpit, and we are here to clarify how our work is. Thank you.
Thank you very much. So tonight, on va savoir ce qu'il y a derrière le décor de l'aviation. So now we are going to ask you some questions. Are you ready? Okay. So let's start. I take my list and I see the first question. Maybe I can ask you the first question, Inanno. So the first one is, why the window covers must be up during takeoff and landing? Do you have an idea?
What could be interesting questions? Well, I really have no idea. I don't know. For the pilot, I don't know. I have no idea. Maybe, no.
If I would have to answer, I have no idea neither, but maybe I could say it's because it's during takeoff and landing, and the plane is of course at the airport. And if the window is open, we can see the flights name companies, and it's maybe advertisement. So, interesting. So, I ask you the question now. For the first thing, you can choose between two possibilities. So the first one, the answer A, is for reason of safety. The second choice, B, is disturbing the pilot. So people who think it's A, it's for reason of safety, can now put the hands up. Okay, well done. And who thinks it's the second choice? Can? Okay, 2, 3, okay. And I don't know what's the good answer.
Let's listen to the experts. Maybe it's better.
Well, I see that people are quite aware. They're all experts, so it's exactly, it's for safety reasons. One main reason is that passengers have to be sort of acclimatized to the external level of lighting. So in case of emergency, they won't waste time in finding the exit and being instructed by the flight crew. And an important reason is also for rescue teams that in case of emergency we'll have to very quickly localize the people inside the aircraft and come to rescue them. So the interior of the plane has to be visible from the outside. So safety, that's the correct answer. Maybe Philippe wants to...
No, you're fully right. And by the same token, that's why the lights are dimmed for landing at night. Same as for the window blinds.
Okay, second question. Are you ready? Yes. Okay, perfect. So the second question is, can airplanes be endangered, sorry for my bad accent, by a lightning? A is yes, and B is no.
Airplane can be endangered by lightning, can be damaged by lightning.
Yes.
Okay.
Thank you, Inano.
What do you think? Do you think that airplanes can be damaged by lightning? Does anybody have the answer?
The plane or the passenger is really different.
The plane.
Thank you. So who thinks it's yes can now put the hands up.
Yeah, of course.
Yeah.
Little.
Who thinks it's no? It's 50-50. Okay. Is someone an idea to explain the choice of yes or no? Someone brave? Okay. So what was the good answer, please?
So, in principle, the correct answer is no, because as you might know, lightnings are caused by a difference in voltage, in electrical voltage, and normally a plane is insulated like a Faraday cage. So, supposedly a lightning shouldn't put in danger neither the aircraft nor the passengers on board the aircraft. Although there are reported cases of damages to the avionics of the aircraft, which are electronic systems, and with the lightning, with a sudden increase in the voltage, could be damaged. Anyway, lightnings are connected to storms and to high turbulence, so as a normal practice, air traffic controllers tend to divert aircraft if they foresee that the aircraft is going through a storm. So in case it happens, normally it shouldn't be a problem, but again, as a form of prevention, normally air traffic controllers tend to deviate the course of the aircraft.
Yeah, fully agree. As you could have guessed. Yeah. No, that's fine. I mean, we can go on. Indeed, it's quite spectacular lightning strike, but it's not very dangerous per se. 2 months ago, I was sitting next the left engine as a passenger on a A330 from BA out of Heathrow, and then I heard a huge bang with a flame coming out of the engine. I initially saw the pilot. That's probably a compressor store, like a surge, and where the flame goes to the front. And then just the captain announced, yeah, it was just a lightning strike. I didn't see the lightning, but just heard a bang, and it didn't damage the engine. Indeed, there are instances of more degradation on the avionics. When you get close to an area where there is some electrical activity, like close to a storm, and you don't need to be 5 kilometers away, even further away, you can hear on your radio the communication are going down very, very quickly, and not only the frequency we use normally, the VHF, but other frequencies as well. Sometimes you can stop, you have no reception at all because of the thunderstorm is between you and the transmitting station, for example. Just will play as a wall. Also linked to the electric activity is the Sint Elmo's fire. Have you heard about Sint Elmo's fire? What's that in?
Yeah, I heard it.
Yeah, it's quite amazing. It's like some greenish bluish light just flowing around. And well, I thought it could not come inside, but that was a year ago. I had my hands on the console in the cockpit, and it was quite a lot of electric activity, but we were just avoiding the thunderstorm. And we saw some St. Elmo's fire on the cockpit, and then all of a sudden I saw an arc just from the window to my hand, just like, ooh. It was like a bite, but not very serious, but it's sort of like, so there is some activity, and if you get too close to it, there is an arc sometimes. So it makes a little hole in the fuselage, that's a spot of lighting sometimes. Also, it's very rare case, I haven't heard anything myself, but some laws of electricity, like the law of Laplace, makes that if there is a current going through a conductor, a metal conductor, and in the airplanes, I mean the skin is, a lot of is aluminium or even composite now, but you still have the spars, the main beams on the airplane. And if you could have sometimes two parallel beams, if there is a current going same direction or opposite direction, they could be forced to go to each other or away. They could have some deformation. But I haven't heard it personally, but it's very theoretical. So I haven't heard it myself. So anyway, we avoid thunderstorms. Not in the first place for the lightnings, but for the rest. Thunderstorms, I mean turbulence, heavy turbulence, hail, donc les grêlons, hagel in the Netherlands. Les grêlons can seriously damage airplanes. So we can talk about thunderstorm later if you want.
Okay, thank you very much. Before the third question, ask someone among you a question to ask. Not now? Ah, yes?
Thank you. I'm very interested in aviation, by the way. That's why I'm here. But one question is how close we are for the cabrio airplanes? Cabrio airplanes, yeah. So I've seen some pictures that some airplanes with some glass top, so that the passengers can see outside what's going on. But is it really something possible for the technology, or still we need steel and rivets for the planes?
Okay.
Do you like the question?
Yeah, I mean it's the reason why planes are built that way is for obviously for structural reasons. As you might guess, the higher you go in the sky, and the lower the pressure, the external pressure, while the pressure in the cabin has to be kept at levels which are bearable by passengers. So still the modern aircraft which fly around 35,000 feet are pressurized, meaning that the pressure in the cabin is kept at a level which allows passengers to breathe and to live normally. The higher you go, and what is important from a structural point of view is that pressure difference between the interior or the plane and the external world. So provided that a material like transparent glass material can grant this structural resistance, I don't see any hindrance in having a transparent aircraft fuselage where you can see the outside world. So if it's from a material perspective feasible, why not?
Thank you.
Now, if talking about Cabrio, you can fly without cockpit. I mean, all airplanes, like biplanes, you can fly and just fill the air. It's still possible. I flew some of those many years ago, but that's the original Cabrio, but it doesn't go very far, I'm afraid.
You said that basically the plane is safe in terms of storm because lightning, because it's a Faraday carriage, it's a conductor. So. And of course, you as a pilot, you try to avoid to go into the storm. But how accurate is the information that you receive, and how in advance you know if there is a storm? I mean, I guess is there any chance that you jump in a storm without knowing it, and then...
Want me to take this one? Yes, of course. First of all, there is a planning phase. Every time an airline has to fly, there is a planning phase where you look at the weather situation. And we have maps that we call significant weather charts, going from 10,000 feet to 45,000 feet, showing all the significance, significant for the flight, not per se, but significance for aviators, amongst which ash clouds or volcanic activity, clear turbulence, and area of thunderstorms as well. Now, there are different reasons for a thunderstorm to appear, but it's usually mentioned, the area are mentioned, but they are not precisely mentioned. So when you fly, you know that you might have to cross a zone of turbulence. A zone of thunderstorms. That's why we have a radar. We have a weather radar, and the radar is built. Is built to take into account the size of the droplets of water. And in the cockpit there is a layout with different colors that will show to the pilot, in function of the size of the droplets, the severity of the storm. Because usually the size of the storm and the severity is related to the size of the droplets. In big thunderstorm you have big droplets. It's not perfect, because sometimes you might have turbulence or at night without any good radar picture. But first of all, based on that. Also, pilots report. Every time in flight, commercial airline hates to make their passenger unhappy, because that's how they live, they need money. So they need to avoid turbulence, any sort of turbulence. So usually ATC knows that in this area there isn't thunderstorm reported or turbulence reported. So that's not a mean of knowing for us. At night it's a bit more difficult. During the day it's very easy to see it. Now you have to be very, very cautious, and don't think you can just fly 2 kilometers away. You have to be far away. I mean, sometimes we're talking in nautical miles, which is 1.8 kilometers. And we use nautical miles because nautical miles is also the length of a degree of latitude, so that's why we use nautical miles. And knots, which is nautical mile per hour. And you can sometimes have to fly 20 miles from thunderstorm, and also to look at the wind. You can fly closer if it's downwind, or if it's upwind. If it's downwind, you have to fly further away. Does it answer your question?
Thank you for the question. Other question? Could you come?
So it's about stealth planes, because I always wondered why they don't show up in the radar. It's because of their material or the shape? The stealth planes, why they don't show up in the radar?
Okay.
We cannot answer that question.
Okay. So there are, first of all, no. Okay. There are two types of radar. First of all, there are active radars, so-called primary radars, and passive radars. Active radars need a transponder to interrogate, let's say, the information, interrogate the aircraft on their position, and the aircraft will forecast back the information about position, speed, and everything, and it will report to the radar. So an active radar is for an aircraft that wants to be seen. Then you have a different radar, which is a passive radar, secondary surveillance radar, which is based on information broadcasted by the aircraft, not voluntarily. Like the radar is scanning the environment, and based on the it's a wave, so an energy wave, a magnetic wave, which is broadcasting in the ether, and when coming back, because it's the same principle. I don't know if you are familiar with bats and the way they see in the dark. Based on the frequency of the signal that bounces back from the object, which is hit by the energy, can detect whether there's an object or not. Now, due to the shape, the particular shape, and the color, right? Because normally they are black, so they. I'm sorry.
It's help from a partner.
So normally stealth technologies are based on color, so black. They absorb the energy, the light energy, all the wavelength of the light, and on the shape. Because of the particular shape, they tend to deviate the waves emitted by the radar, so that the information is not sent back to the main radar and is not detected. Did I?
It's the same material as the other aircraft?
It's both the color, the material, and the shape.
But the same alliance, the same metal.
It's quite hard to say. The same type of material.
Same type of material? As what sort?
Okay. It's quite kind.
Oh no, it's the varnish, which is different.
The paint.
Yeah.
Actually, I used to be an electronic warfare officer for my squadron, so I went to some advanced electronic warfare course, and it's a very sensitive topic. Even they won't tell you about it, but it's in fact due to many things. You want to be stealth on the radar spectrum, because there is a huge band. I mean, the spectrum is visual, infrared, radar, and airplanes are designed to be, the first stealth airplane were designed for a special frequency band. Indeed, you have different technologies. You can try and trap the emitted ray. So you have a radar emitting, and you try to catch the emission and make it turn in every direction, so there won't be almost any energy coming back out of the airplane. The infrared signature is important for infrared guided missiles, so you want to have a lower infrared signature as well. Paint is one of the technology. You can also have some active systems, like they analyze the signal and they just send it back in phase or position, so just going to disappear. So there are many technologies around it, but it's usually classified stuff, and it's quite a long time ago for me, so I know the basics of it. I remember the basics of it, but I know that when they asked me when I was flying the F-16 why I had that missile on my side, that I had to lie about it. So, well.
Okay, so I see in my list a question I really would like to know the answer. So the question is, what is the major reason for flight delays?
We love it.
Possible answers: A, weather conditions, or B, technical problems. Who do you think it's A? Can now put the hands up.
The pilot.
Okay. And who think it's B, the good answer?
I think it's B.
Okay, it's 50-50, and I'm sorry, because none of them are correct. but what's the good answer? Who has an idea? Could you come, please? Traffic jump, yes. Thank you. Sorry?
Airport management.
Okay. Airport management. Other ideas?
No.
Passengers, yes, of course. Something else before the good answers? Maybe your answers are good too.
All right. So let's first define what is a delay. Delay in takeoff and landing is when an aircraft is late on the schedule by more than 50 minutes. As you know, slots are given to for takeoff or to airports, and normally they have a window of 50 minutes. So if it overtakes that 15-minute window, normally it's considered already a delay. Then all of the reasons that have been mentioned are valid. The main reason still is, unfortunately, for an aircraft arriving late to the apron, and then there's a process which is called turnover, and the aircraft has to be ready for the subsequent flight. So that's still the main reason, but weather conditions, for example, can cause a delay if the visibility at the arrival airport is low. Then, of course, the capacity, the runway capacity, will diminish, and as a consequence, the air traffic controllers will divert some of the flights. There can be other reasons like high congested air sectors due to some particular events. So this is managed at level of air traffic management, and normally they prefer to keep a plane on the ground if they foresee that it's going to be a delay, because of course the fuel on board is limited, and then you cannot keep an aircraft on hold for more than 30 minutes, so you don't want to be and end up without fuel. So normally it's a ground delay, and it's managed at network level. But so all of the reasons again are true. So unfortunately, nowadays still the first cause for delay is air carrier delay, meaning that the aircraft is not there at the time where it should be. If you want to.
Oh, sorry. Yeah, fully right. And maybe just one point. Usually, the most important reason is the late arriving aircraft. The aircraft is late because something happened before, which is usually linked to the slot and everything again. So, in turn, I mean, if you look at the statistics, that's airplane arriving late, but for some good reason usually. Whether, once there is a unforeseen or not so well foreseen weather system with snow, and you have lower capacity, you mentioned that, we need to de-ice airplane, that's important. It's a long process, and if the protection that we have when we de-ice or anti-ice afterwards doesn't last very long, depending the temperature, the type of fluid we use, the winds and everything. And sometimes we have to go back to the stand to wash the airplane away again and apply a layer of anti-ice. Many accidents in aviation have happened because the airplane was not de-iced or not properly de-iced. So it's very critical, and I know it's tough. I was going back home after 6 days of work. I was in Frankfurt, and they let the passenger board the airplane. We spent 2.5 hours in the airplane in the winter, just waiting in the de-icing queue. So it's quite frustrating, those delays in airports. But you mentioned pretty much it. Yeah.
Yes, I see questions.
I have a follow-up question to what you said about de-icing. I have seen that they sometimes de-ice at temperatures close to 0 degrees, but they don't de-ice, for example, when it is minus 15 or so. Or I don't know if it is right or wrong, but could you explain that?
Okay, first, why they don't de-ice if it's minus 15? What is dangerous for an aircraft, it's the wing profile. And you always, I don't know if you have seen the profile of a wing. And forgive my drawing, but if this is the airflow here, and this is the flow of the wing, pretty much the leading edge and the trailing edge here. The profile of the wing is designed to produce a good lift. If you have some precipitation sticking on the wing, not only will it add some weight, because ice is quite heavy, and if you take something like 50 square meters, it's a lot of weight. Could be above, I mean, 1 or 2 tons sometimes. So if it's minus 15 and it's completely dry, usually we touch the wing. We go and touch the surface to see if the surface is clean. If it's clean, there is no ice. I was in Italy not so long ago. It was minus 3, nothing on the wing. Very dry. Geneva the same, very dry, minus 3, no need to anti-ice or to de-ice. Now, if there is only frost due to the night, morning frost, there is a little amount of frost on the wing. That only, it's not a reason of weight, but that only will degrade the lift performance of the wing dramatically. And we're talking about 30% of less drag, less lift, sorry. So because of that, you could be in danger for takeoff. So even for, you could remove it with your hands. You do that, it goes away. You need to de-ice for that. Now you don't need to anti-ice. You don't expect precipitation. It's usually a dual process. It takes place at one. You don't see, unless you look at the color of the fluid. If you see some orange colored fluid, that's the de-icing fluid. It's usually a mix of water, and we call it type 1. It's heated around 60 degrees. It will melt the ice or whatever it is off the wing. And then we apply another layer of anti-ice fluid, which is sort of gel on the wing. It's usually greenish, yellowish color on the wing. And this will absorb the water. If it's snowing, whatever, it will melt, and it will still be kept in the fluid until a certain limit of time, which is function of the temperature, of the quantity of snow, if it's light snow, moderate, heavy snow. And at some stage, the fluid will be too full of water and will not play its role of holding the water, and it will start to freeze on the wing. That's why sometimes we need to go back. So, first question, it's dry, no precipitation, nothing, we don't de-ice. Now it's warm, it's 2 degrees, but still you see people de-icing. Why is that? Because for example, it's raining. The aircraft has been flying for about 2 hours at about minus 50 degrees. It lands, the fuel is at about minus 30, minus 40 degrees. It starts raining, and the rain will automatically freeze on the wing. And you will don't pay attention, that's very naughty. That's why we look always around the airplane, even in positive temperature, we say, oh, shit, we have ice on the wing. Because it's clear ice, and clear ice you don't see it. So you really have to be very cautious about it. And that's why we de-ice sometimes with positive temperature.
Can you please briefly explain the way the jet stream works and why 10,000 meters is the best altitude to fly at?
Okay. Maybe the drawing is good because based on that you can explain. So this is the scheme of an airfoil, and basically this is the section of a wing, and the lift, so the force produced by the shape. Is what is lifting the plane up in the sky, right? And this is due to the fact that you produce a difference in pressure from the outside part, the upper part of the airfoil and the lower part. So basically the difference in pressure, because particles that will hit the leading edge will have to, for a theorem, this is mathematics, will arrive at the same time at the end of the trailing edge. And for going along the pathway, which is longer, they will have to be faster. And there's a theorem, it's the Bernoulli theorem, says that the pressure and velocity of particles are, their sum must remain constant. And so when particles go faster, the static pressure will be lower, and this will produce a pressure difference which again will result in a force which is called the lift. This is what is lifting a plane in the sky. And the lift is normally
This is a lesson of science.
right. It's linked.
Now explain, because we don't understand anything.
It's linked to the density, to the air density, which is a function of the altitude. So the higher you go, and the lower the air density, and it's a linear function. The squared of velocity of the air or the stream, the surface, and a coefficient which is the lift coefficient. When a plane is in a cruise phase, normally forces are in equilibrium, meaning that the weight and the lift have to be equal, just to keep horizontal and steady flight. So now, what is varying? The weight. Why the weight of a plane is varying during the flight? Now, this is my question. You have an answer? You want me to? Okay, because the fuel on board is diminished, of course. It's being burnt during the flight, so overall this will diminish along the flight. So in order to keep this constant and diminishing, you have two options. Whether you go up, and this is it's called continuous climb, or whether you slightly diminish the speed until to keep the equilibrium, let's say, between the two forces. I haven't mentioned that there are two forces which is also balanced in themselves. So one is the drag, the induced drag, and one is the thrust. Thrust comes from the engine, and drag has different components, but one is the aerodynamic drag, and one is the induced drag. But anyway, when you look at the altitude, the cruise altitude, that's the optimum that optimizes the fuel consumption. Still, the equilibrium between these two forces, the lift and the weight. And for commercial reasons, there are different flight levels, let's say. So it's not a fixed altitude, but it can slightly vary. Normally, correct me if I'm wrong, but the reduced vertical minimum separation is some 1,000 feet, meaning about 300 meters. So planes can fly different layers, one on top of each other, at a distance of about 300 meters, with still keeping a good level of safety. Did I reply to a question?
What's the jet stream?
Yeah. May I?
Oh, sorry, the jet stream was.
Yeah, I was wondering where you're going to.
Sorry. Right.
This is entirely correct. What it is. You mean about the jet, the lines you see in the sky?
No.
Oh, the weather, yeah, the jet stream. Yes, I can. Okay. May I? This is some climatology stuff, some weather-related stuff. It is. Okay. Thank you. So, if this is the Earth here and the atmosphere, it's a little bit like an egg. The atmosphere is a bit lower here than here. If you take, let's say, Europe somewhere like that, with the Isle, okay, Spain, France, okay. You have actually, well, first of all, you have several layers in the atmosphere. The first layer, where you have all the weather phenomena, is the troposphere. The troposphere is limited by the tropopause, which varies every day, and on top of it is the stratosphere. Usually the temperature goes down from the ground to the troposphere. It stays pretty much the same for a while, then goes it's warmer again. But this layer is not a constant layer. You have actually two interruptions in this. If this is a tropopause around the Earth, there is a big interruption here. Actually, there is one here quite high. There is one here pretty much our latitude, and there is another one close to the pole. Now, depending the situation, high pressure, low pressures, those zone moves. Now, because there is a discontinuity over here, usually there is a big hole here and a big hole here, and that's usually where the jet stream will happen. Now, depending the day, you can have the tropopause at 27,000 feet, and you can have it at 40,000 feet. Winter and summer is different. Usually the winter, we get more the polar one, and in the summer we get more this one from the 30, 40 degrees latitude. Just the air go through it, and it's quite impressive, and the gradients of speed will give the turbulence, basically. It's very useful when you fly with a jet in your back. You just fly to like in Nemo, was it Nemo, where the turtle would go in the stream. That's what we do to save some fuel and to go faster. And if we had some jet ahead, we will fly lower. Even flying lower is more a penalty for consumption, but the combination of headwind and could be better for you to fly, for example, at 20,000 feet. I had the example of a guy who flew in the Rhone Valley on a little twin aircraft, and look at its ground speed and say, well, we're stationary, shall we land? Because the jet was so strong where it was flying. So, is this answering your question? Thank you.
Thank you. So now I have a young man who has a question. What's your name? Jacob. Is it in English, in French? Okay, en français.
Pourquoi doit-on éteindre les lumières au décollage et à l'atterrissage? Pourquoi doit-on éteindre les lumières au décollage et à l'atterrissage?
In English? Thank you very much. So
this basically has to... Yeah. Why do lights have to be switched off during a takeoff and landing? Okay, this is a bit related to the first question on why the shades from windows have to... Ok, je peux essayer de le faire en français. Mon français c'est pas... Donc ça c'est un peu lié à la première question qu'on a eue. Pourquoi les fenêtres des avions doivent être ouvertes au décollage et aux atterrissages? En fait, c'est pour des raisons de sécurité. Donc, les passagers, ils doivent être un peu acclimatisés au niveau de lumière qu'on a à l'extérieur de l'avion. Donc, en cas d'émergence, ils doivent être tout de suite capables de sortir de l'avion dans les temps les plus vite possible. Donc, en parlant de les lumières, dans le cas d'émergence, il y a des lumières d'émergence à bord de l'avion qui indiquent la sortie d'émergence pour les passagers. Et normalement, en cas d'émergence, il n'y a que les lumières d'émergence. Et donc, c'est aussi pour question de sécurité. Pour les passagers, c'est acclimatisé à le niveau de lumière qu'ils ont et pour pouvoir voir les lumières d'émergence dans un cas d'émergence. Au décollage comme en atterrissage. J'espère que...
You quickly say it in English also for the others, right. Please. Thank you.
Okay, so I was saying in French that this is a bit related to the first question. So why have window shades to be up in the up position when taking off or landing? Because it's for safety reasons, so for passengers to get acclimatized to the level of light that you have outside the aircraft. And again, in case of emergency, the only light functioning will be the emergency lights that indicate the emergency exit. So it's for both the passengers to get used to the emergency lights, because they are normally late during demonstrations at the very beginning. So it's the safety reasons is the main question in case of emergency.
Thank you.
I don't know if you.
Can I also ask a question? Can you explain us why we have to switch off all the mobiles, laptop, and why all the electronic devices must be switched off during takeoff and landing? This is, I think, a question that everyone is interested to know.
Okay. So yes, indeed, this is something that is normally required from flight attendants. They remind everybody to switch off their mobile devices. And now the question is why? Again, it's for safety reasons, because mobile devices normally are equipped with an antenna which is emitting waves, electromagnetic waves, that can interfere with the avionics, the onboard avionics, especially the ones for communication and navigation. So when a plane, for example, is landing, it receives the signal from a so-called ILS, Instrument Landing System, based on there's a signal processing, so the information signal is modulated with a carrier wave, and if an antenna is emitting waves, it can interfere with the wave produced by the ILS, and it can transmit false information, so leading an aircraft to land where it shouldn't. This is also true for GPS receivers on board, which are more and more used, and maybe Jean.
No, you're fully right. We use usually VHF frequencies, which is within 300 megahertz. That's the same as the radio stations, by the way. We have normally resistant receivers. Now, one thing to remember: you can't hide. We hear you. Every time a mobile phone is turned off or on, still on, we can hear it in the speakers, in the headset. It's even from the back of the airplane. We okay, there's another one with the mobile phone. Tell them to switch it off. Okay. I mean, it's not a problem. A little something to hear. We use it for navigation, normal navigation, but we use less more the GPS for the long-range navigation and for even the approach itself. Now the big danger is in case of really crap weather. When I say crap weather, it's something like 75 meters visibility and zero ceiling. By that, you're always glad to be able to take off and land when it's really bad weather. You don't want to hear, sorry, your flight is cancelled due to weather. So some airplanes, not every, I mean, my airplane is not equipped with that sort of ILS. There are several categories. Category 1, 2, 3, Alpha, Bravo, and so on. Category 1, you can land with about 550 meters visibility and around 200 feet ceiling. At the end, the pilots, so it's pretty much 60 meters elevation. And the pilot can see at the end, he sees the runway, yes, he lands, doesn't see, just go around. Cat 2 is a little bit lower, and the Cat 3 is really low. It's too low for the human being to be able to do it by himself. It's all automatic. That's why you have the autopilot. It's what we call a coupled approach. There are several autopilots, not only one, because it's fail-safe, of course. And now the most modern airplanes are equipped with those systems. So several autopilots checking each other and say this is not a good one. They compare, there are usually 3, and they compare the good one, they switch off the bad one and everything. So there are some redundancy. But it's all automatic. It means the pilot, they have to do at least once a month to qualify the aircraft, to check the system is good, and to qualify the pilot as well. So they don't touch anything, they monitor the approach. How is it actually? Just a brief, if I may, just a brief drawing. Basically, the pilot in his aircraft will see a circle with 2 lines. It means it's on the glide, is on the correct glide, and it's the correct track, the runway axis, basically. And on the runway, as Andrea was saying, this is the center line of the runway, and there are emitter here, and they will emit. That's the emission diagram of the DRS with 50 and 150.
90 and 150.
90 and 150. Thank you. The blue and the yellow one. And in the middle, that's right. In the middle, you receive the same. So if you go left or right, you will receive less. Now, if there is some sort of disturbance, and you're flying all automatic, I mean, there is an auto throttle. You don't touch the throttle. The aircraft will say, "Oh, I'm going too slow. I'm accelerating." Yeah, good move. The aircraft will land by itself. It will brake by itself. It will retard the throttle by itself. And will follow the center line. There is a line. It will follow the line. The pilot just needs to take his jacket and get out of the aircraft and feels like, "Oh, have you seen that? Oh, how good I am." So that's it. If some interference appears, the system will always try to find this. And if in the air you might have, instead of a beautiful line, you might have a line like that. This is not too noticeable in azimuth, but you might have the impression sometimes when you fly that the aircraft goes up and down like that. It's just because the glide, usually the glide is more sensitive, and is usually, if this is the ground, the glide is usually a little bit like that, a little bit bent by, could be houses there, could be steel industry, could be everything. Now, when the weather is really bad, there is a procedure that is called low visibility procedure. And when there is low visibility procedure, if this is a runway, for example, with a holding point, if the weather is nice, you will have what we call a Cat 1 holding point. If the weather is bad, they will say to the airplane, "Please stop here," because the proximity of the metal of the airframe of the airplane will have an influence on the signal. Even a car, they will stop traffic and everything to make sure that the signal is not deformed, is not changed by the proximity of the metal. That's just what I wanted to add.
Okay, thank you. I remember once. Who has a question? Okay, about phone. Yes.
What is the time?
Wait for the micro, sorry. Otherwise we can't hear.
Let's say hi. Let's say you're approaching and you see something wrong with the signals, and what is the time to disengage the autopilot and take over?
The danger with the interference is that there will be no signal to tell you it's wrong. How can you know? I mean, the machine is working perfectly.
Go down, you have the lights.
Yeah, of course we have the approach lights, but if it's really zero ceiling and 75 meters, you won't see the light. I mean, it's just automatic. But the danger with the interference is that for the machine, it seems a perfect signal, so we will just follow it. And I don't know what the reason was for that, but I know there was a BA 747 who just flew next to the runway, almost hit the tower not too long ago. Oh, sorry, I shouldn't have named a company name, but could happen to everybody. I mean, it's just sorry, no BA guy.
That's a friend.
I have another question here.
Okay, actually I have two questions, and the first one is going back to mobile phones and all the equipment on board. As far as I know, some companies like Airbus and Boeing, they represented aircraft where you can use mobile phone and internet on board, especially for long-range aircraft flights. And the second question, can I ask two? Yeah, because you never know later on. And the second one, international organizations like, let's see, Eurocontrol and program as NextGen, they represented the ASA's system, its airborne separation and avoidance system. And I'm just curious, that's like from pilot's point of view, do they trust this system? Because let's say on free routine airspace, it's possible that you might enter some restricted area and etc. Just like this.
Yeah, all right. Take the first questions. So, as you said, on some air carriers, now there is a possibility to have conversation with mobile devices. Again, this is not true in takeoff and landings for the reason that we just mentioned. So the plane needs to to land where it's supposed to land. So if there is an interference, the onboard equipment might not detect that it's landing where it shouldn't. During cruise is different because we don't have this interference with ground communication. There are new technologies, picocells they're called, allowing communication because they broadcast at a frequency which normally doesn't have interference, doesn't produce interference with the avionics, so at a different frequency. Again, if you are familiar with the concept of interference, you have interference where the amplitude or the frequency of the wave are similar. And so there's a mathematical function that says that they will add one to each other and produce an interference. If the wavelength is quite different from the one of the signal used by the avionics, there will be no interference, and normally then during the cruise it's possible to communicate. So these picocells, they capture the signal from the satellite GPS, and then they have a sort of a switcher to communicate with all mobile phones on board. So they give possibilities to more than one person to communicate at the same time and using the same channel. Maybe he wants to talk about the SSA, the airport separation program.
If I could just add something, isn't the real problem that traveling would be hell if 100-something people having nothing better to do suddenly started talking on their mobile phones, one next to each other, in one small confined space?
That's why it's so expensive.
Now, I witnessed in London City Airport a bunch of eight friends just traveling together, and they were sitting next together and sending text and post on whatever among each other. I'm not from that generation, I'm afraid, but yeah. But by the way, you can. A friend of mine just he had good fun. He just went to Australia and he bought a jammer, a mobile phone jammer, and when he was fed up with somebody's calling him, he was there turning this mobile phone on, his jammer on, and the guy was just like lost in space. But yeah, I'm sorry, I'm not supposed to advertise for that.
Thank you.
The question was about the collision and avoiding system? Yes, okay. It's
airborne separation and avoidance system.
Yeah, it's the ASAS.
It's not the ACAS,
No,
sorry.
No.
You mean the separation between airplanes?
Yes.
Okay, yeah, oh.
The pilots, they're gonna separate themselves.
Yeah, well, you can, well, I can start and maybe add something if you want to. There are reasons for separation. One of the reasons is because of the turbulence created by the airplane, what we call the wake turbulence. It is so dangerous that it has caused some crashes. So there are different airplane categories: light airplanes, medium airplanes, heavy. And now there is one category, or one aircraft in the next new category, the super, which is the Airbus A380. And there is a separation requirement for landing and one for takeoff. Landing is usually in nautical miles, and it's always compared between categories. You don't need separation between a medium and a medium, but you need a separation, a 2-minute separation. Sorry, for landing it's a 5-mile separation between a light. I mean, if a light wants to land behind a medium, and so on. It goes depending which versus which, but a light versus a super, it's a lot. It's 7 or 8 miles, and timing for the takeoff is the same. The reason for that: once an airplane is flying, lift is created, and because I was going to draw this one, but I do another drawing. As my colleagues said, he started with the lift formula, you all remember. But basically, on the wing, oops, sorry, there is here a zone with a lot of depression, and here a small zone with some pressure, some positive pressure, because of the flow of the wing and so on. But what's happening is that if you look to the front, you have some negative pressure and some positive pressure here. So this pressure wants to go up here. And what's happening, if you look behind an airplane, if you take the airplane like here, at the end of the wing, you will start to have a turbulence like this. And I'm not exaggerating, it's as big as that. So, what happens if a little airplane flies here? It will do like onto the ground. And that's why we need, of course, it's very dangerous when there is almost no wind. When there is enough side, a crosswind, there's not a big problem because it will blow away and everything. So that's also one of the reasons for the turbulence, by the way. If you fly in somebody else's flight path a little bit below, and the guys pass about 1 minute below, the time, this turbulence will about descend by 1,000 feet about by 1 minute. So if you fly there, the guy was there, you can be sure you will find this turbulence, and you go, and it could be like, you know, 20 degrees, 30 degrees on the bank, all the coffee everywhere. So that's it. Let you go with it.
Yeah, so you mentioned the ASAs. I know this is one of the future capabilities both of the NIJET and the SESAR projects. So basically the concept is that the delegation to the pilot of the task of keeping separation, because one of the tasks of an air traffic controller, the main task I would say, is to keep separation because of wave turbulence and also for safety reasons between aircraft. And there are en route air traffic controllers, TMA, and ground traffic controllers, let's say runway traffic controllers, giving clearance to each of the aircraft when entering the sector. Now, these in the future, aircraft will be able to separate themselves through technologies that allow to predict in position and time the trajectory of the airplane. So these so-called I4D technologies. This is something recently developed and being tested now. So in the future, the trajectory, each aircraft will be aware in itself and all the surrounding traffic, when equipped with the right technologies, aware of the forecasted trajectory and cleared by en route controllers at each phase of the flight. So in the future it will be possible to have this self-kept separation. So the separation task delegated to the pilot, to the aircraft, due to these automation systems, and not anymore to the air traffic controller.
Yes, but for example, in such airports as CDG, when the aircraft are landing, like landing every 90 seconds, pilots will trust the system instead of the air traffic controller, who has like a lot of experience.
Normally the air traffic controller will be still in the tower, supervising the process. But
so the air traffic controller, its function just will be like on one monitor?
Yes, that's basically the concept. I mean, there will be always a human behind any machine. So, provided that everything will go according to plans, there will be no need for the air traffic controller to intervene and to let's say cancel a clearance that has been given to the system. But in principle, the process of giving clearance to landing aircraft will be automated. Yes.
Just may add a little something as well. Sometimes ATC asks you if you are visual. It will allow them, it will remove the responsibility, and it will allow you to have another separation. Because I was talking about the wake turbulence, but also the separation, as Aaron Duran mentioned. And by acknowledging the position of the aircraft, say, are you happy to go behind him? And it's your own responsibility to do that. Also, sometimes it is so tight, especially on single operating runways, like Geneva, it's on one runway. There are other places with a single runway, like London City. It's really tight. Say that the pilot, for some reason, has a little glitch. I say, oh wait, we're only 20 seconds late in the checklist. And everything is screwed up. Could be, when you fly, you're given a speed to fly. They say, okay, your call sign, maintain 160 knots to 6 miles, maintain the speed. But sometimes, I mean, legally, it means +5, -5. Now, sometimes say, well, 160, we're going to fly 155 today, or 165 today. But if everybody does that, sometimes you will end up with lower separation. And it happens that I'm flying a quite slow airplane. It's a jet, but it's quite slow compared to others. So sometimes we have to reduce, and the controller just managed to put everybody in in a row, but it's really too short. He said to the guy after, you just, sorry guy, just go ahead, I'll just go around. And wow, that's it, he has to go around for another tour.
So that was the question, for example, like in the airports, like the city, when those are double jet, there's a 3 runway with less than 3 nautical miles. In past, will be able to maintain the separation.
You talk about simultaneous approaches.
Okay, let's see.
Could you come, please?
Yeah.
What's your name? Okay, Victoria. Nice to meet you.
The question is, let's say at the airports like Charles de Gaulle, when you have 2 land, yeah, it's in general it's 4 runways, but you have 2 for takeoff and 2 for landings. Close there is Le Bourget Airport, the 3rd runway for landing. And with the ASA system, pilots, they will be able to maintain the separation by themselves. As far as I know, between the runways, there are less than 3 nautical, miles separation, so they should be separated by the altitudes. And the question is, in this situation, if pilots, they will be able to maintain the separation, because that airspace, it's complex, it's extremely complex. That's all. Thank you. Thank you very much.
If I may say something, this is quite a technical question, but runways normally, as for independent arrivals, there's a prescribed distance between runways. It's normally, I think, according to
750 meters, I think. Between runways to be able to
935.
Okay.
But I mean, it's less than 1,000 meters, so it's definitely less than 3 nautical miles. So the question is, yes,
it's less than
they will be able to, they will be able to have some simultaneous arrivals on even on parallel runways, still being able to self-separating themselves.
Another question here. There is one question here.
Yes, I'd like to ask a question about fuel. About how much fuel does the plane use? Are there basically, is there a tendency like in car industry to save fuel as much as possible? And above all, how much does it cost, for example, to fill up a plane, a regular passenger plane?
It's like quite many questions per itself. How much the airplanes uses is function of the weight of the airplanes, the size and everything. So I fly a little airplane with 7 passengers on board when it's quite light. We go fly high. I burn 700 pounds an hour, which is not a lot. Now you could have. When I was flying the F-16, I was just taking off or putting full burner in air combat. I was burning 10 liters a second. So. So I mean, big airplanes take a lot more fuel. So that's why we try to fly as high as we can, because of the air density, there is less resistance, and so we fly, and the engines consume less. So we fly higher to save money. But I mean, the fuel bill for companies are quite big. Now, my company uses a system with a percentage. They know every company has deals. They talk to fuel suppliers. They talk to Shell, ExxonMobil, anybody. Every year they renew the contract. They say, I'm going to work with you. How much do you offer? And you have price everywhere at different airports. So the fuel can vary from 1 to double. I'm not counting about tax. Some countries have a tax system that will double the fuel price because it's an internal fuel and not an international flight and everything. So it's quite complex. And we use a matrix based on 100% in this area. And then based on that, we try and take what we call economical fuel. So we take more fuel than needed, where we know we're going to go to a place where the fuel will be more expensive. But sometimes the fuel comes, do you need fuel? I say, no, we don't need fuel, thanks. So that's it, but probably have something more to add.
Last 10 minutes question time, here and after here.
Does this mean that when we Ryanair fly?
Okay, I have a quick question here, two questions. One is, I have seen that most planes actually do not really fly over the poles, for example. What is the reason for it? Is that lack of airports or something else? The North Pole, for example. And the second question is, there is this perception that the Russian planes are not safe. what is that? Is there a real background for this? Is it maintenance? I mean, considering what is happening actually, some people might want to go to North Korea in the future. So what about the track record of Air Koryo, for example? How can we, like, are they really safe?
Well, about the North Pole, I'm not a long-range guy, so I've had been I've done a few flights long range, but not a lot, so I'm not expert. What I can tell you is, of course, close to the pole you have some problem with magnetic interference and everything. So you need to fly grid system, but not GPS, I don't know how it goes. But a few routes I know goes close by the pole, that's what I know. But when they go to Japan, sometimes or to China, they go very close to the North Pole, but how close I don't know. But I'm not experienced in that. And as far as the second question is concerned, it's a little bit politically sensitive, and everybody's grown up. I mean, I've been flying. I mean, I've landed in Moscow a few times. It's a different sort of organization based on, like everybody in the world. I mean, it's based on the culture, on your culture, industrial background, everything. I mean, but. If they were unsafe, they would be banned to fly in Europe, because Europe has a list of airlines banned to fly. So if they were unsafe, they would be banned. There is maybe a culture thing as well in the pilot community. There is a bit different from the one in the West, where the authority has a bigger role than I mean, if there is an external authority, it's by tradition a very centralized system. And there's still some remaining of that probably in the culture, but that's all I can say about it.
Yes, hello. I have a question about fuel consumption, as you were talking about it before. The other day I was casually looking on a site on the internet about carbon footprint, and as I travel quite a bit, like many people here in Brussels, I was very surprised, a bit taken aback, to be quite frank, in the huge difference the impact flights, I'm talking about 4 flights a year in Europe, had on my carbon footprint. And when you look at something like going to New York and back, well, of course the consumption is huge, but the production of CO2 is incredible. It's like 1/4, if it's correct. I was wondering, is it correct that the CO2 impact is that great? And if it is so, what is being done about it? Is something being done about it?
I think every company has a plan, some sort of plan to, first of all, try and offset the carbon footprint. But the reason for that, I'm not a specialist in environment, but what I believe is that because of the position, as we were talking about, airplanes leave behind them a big stream of, sometimes you see the lines in the sky, so the contrails, condensation trails. And because of the position of those sort of clouds, finally, in the altitude, their impact, it's not a quantity of gas that are exhausted, but it's their position. And it seems their impact, because of the altitude, is quite high on the environment. But just don't quote me. I'm just that's what I heard. And there are a lot of projects with fuel projects about the fuel times. But I'll leave maybe Andreas a better idea of me.
Yeah, exactly. As you just mentioned, I mean, there are not just carbon 2 emissions. There are all the so-called greenhouse gases, which include also the NOxes, the nitrogen oxides. The system for calculating, also I'm not an expert in environmental calculations, but I know that in Europe there was an emission trading scheme according to which each company, each air carrier had to calculate its emissions in terms of tons of CO2, so carbon dioxide. Now, aviation accounts for about 3% of world emissions of carbon dioxide. So it's considerable, but still it's quite limited with respect to other human activities. What was the question? Why aviation is has such a big influence on carbon emissions? I might a bit disagree with the question because of these figures.
I just saw that on an internet site. I was wondering if it's correct. the impact, if you start seeing what I was looking up, I looked a couple of internet sites and I was wondering if it sounded almost too much. Because if you have an apartment, you heat it, you have a small car, you use it, etc. And then when you start putting the flights in, you see the thing going woo, right up.
Maybe figures are correct, but you're not considering something that when you're flying with other people, which will share the carbon footprint with you. So in the end, if you take the global carbon footprint of all these people on that flight and then their everyday activities, still figures are the one I briefly exposed. So the overall impact of aviation on carbon emissions is still quite negligible with respect to other human activities as cars and household eating.
Thank you. We have another question here.
Hello, I have just one practical question. So, in the internet we have the man in the middle concept saying that someone in the middle can be claiming that he's the right person, assuming that you are the plane, and I assume, for example, I hijacked, I interfered, and I play the guy in the middle saying that I am the tower, for example, although I am not. I am a terrorist, for example. So how do you know that? How do you ensure the security of the communication that you are really talking to the tower? And do you use some encryption mechanism or what is that security?
Okay,
how
no,
can we trust?
not in aviation. In civil aviation, there is no transmission security as such. In the military, you have encrypted communications, so that exists. It's based on two different technologies, which is the frequency hop. So you transmit on a frequency band, and the frequency you're transmitting is changing all the time. So it's very hard to intercept your message, and also there is encryptors as well. So it's hard really to know what's in the message as well. There are regularly, for example, in Le Bourget, notice to airmen, we call NOTAMs, that advise communication in French have been heard, don't rely to those communications. It happens sometimes, and we are aware that at some places, some people have a little portable transmitter on the same frequency, and they try to say, turn left, turn right, and yeah. Now, I know a terrorist act can always happen, but well, I don't see, I haven't experienced it myself, but I know it exists and it has happened, and we are sometimes aware of it by a message.
What I maybe wanted to add is that communications, the security is done by, with the redundancy of communications. I mean, normally you have voice communication and then so-called control pilot data link, which is broadcasting information from air traffic centers, air control centers to the aircraft. So you have different sources of information, and to have a terrorist attack that can jeopardize the level of communication is more difficult because of this redundancy in communications between the ATC and the pilot.
Hi. Two questions. One is, could you give us a rough estimation of how much will it cost a flight between Brussels and, say, Barcelona, around 2-hour flight, with a normal airline carrier like Ryanair or EasyJet or Iberia? And second question is, which is your favorite airport to land in Europe, in terms of that has the best landing systems, best runways, so on and so forth?
I was thinking best restaurant, but that's my country. First question is, it's tough to understand the structure cost of a company is quite complex. So, and as a normal line pilot, I'm not involved too much in that. I've been before when I was in the military in the air staff, but it would be hard for me to tell how much it costs the company for that flight. I mean, so sorry for that. And most of Europe is usually well equipped. Big airports are well equipped. Several runways with instrument landing systems. You also have to take into account the fact that we use language, but only native speakers are citizens of the UK. Sometimes Americans say the Brits, but basically they share the same language, although sometimes they don't understand very well. But if you go in a country with an ATC controller has been trained, pilots have been trained, but it's not their mother tongue, it's not their native language. So it's sometimes easier to land on a place where ATC speaks slowly, clearly, with an accent that is easier to understand. And some part of Europe, like Germanic countries, are usually a little bit better at speaking English than southern countries. I'm French speaking, and I know a Dutch speaking guy would probably have a better accent. So that can be taken into account, but usually all very professional. I mean, Zurich is very good. Amsterdam, controllers in Amsterdam are excellent. When you see the amount of traffic they handle, they are one of the best as well. Controllers in the London area, I mean, they must be crazy. I wouldn't take their job for it. No way. We complain about them, but I just can't want them to do their job. It's so crowded there, so they have no time to say goodbye or to say hello. Well, they still take it, but
sorry, it's time for the 2 last questions. So, who? Yes. One and another person maybe who didn't ask question until now. Yes, here. One and yes, and you.
Yeah, I hope you understand what I'm talking about. I know you're Italian or somehow you understand. My question is about the so-called vuoto d'aria, but I don't know how to say it in English. The air jump, basically that thing that happens at some point the airplane just do that and keep going. I don't know the name in English. It's called vuoto d'aria. Yeah, le trou d'air. Yeah, but how do you say it in English?
They don't have a word. You can say wincher, but this is something different.
It's a turbulence. It feels like a hole, like you follow.
Yeah, so I would like to understand. I know that it's not like in the air there's an area where there is no air, but could you elaborate on that?
Yeah, actually there are many ways of having turbulence. We touch a little bit on the clear air turbulence. When talking about jet streams, usually you can have turbulence in clear air because there is a gradient of speed, and that could create a turbulence. Now, what can happen actually when you have a thunderstorm? It starts very gently. There is some air, hot air going up, and it's a certain circumstance of humidity and temperature, and everything, and then it starts building up, and it can build up quite quickly and very violently. And I mean violently. I just flew not so long ago next to a thunderstorm, and I just saw it grow. It was like going up, growing as I was flying next by. So what's happening there is you have very strong wind going up and going down. Now, a little drawing again. That's why I had a visit from kids from the school. I said, you know, drawing and cutting with scissors is very important to become a pilot. So, this is the wing. And as Andrea told you, the wing is producing the lift here. This is the weight, and in straight level flight, the lift equals the weight. Usually the wind is coming like here. It's all about vectors actually. If the wind comes from here, sorry, does everybody see? There is a component, there is an horizontal component and a vertical component. So this vertical component, it will do like this. So you have to say that the lift of an aircraft is function of the lift coefficient. And the lift coefficient is basically function, and the lift coefficient is function of the angle of attack. So the position of the wing related to the airstream. So we have what we call, if this is the, this is about 15 degrees here. This is the, this is the angle of attack, or alpha. And this is the lift, or lift coefficient. If the wind is straight and level like that, it means air will flow and nothing happens. But as soon as you tilt the wing like that, and I suggest you go in your car, 100 per hour, you put your hand outside, you leave it like that, and then all of a sudden you start to tilt it, and then your hands going up. So what's happening? I will not talk anymore about it because I can talk forever. But what's happening? If there is at some stage air going up, here this vertical coefficient will come over here and the aircraft will start going up. But now, all of a sudden, because the air is very turbulent, you have the big cloud here, which is raining here like hell, it's going down, and here, because it's going down, it has to come up somewhere. So here is coming up here on the side. And if you fly here, or close to it, because it could be also on the side, you don't see the cloud, because it could happen here as well, that you don't see it. All of a sudden, you're flying here, and then you're flying there. So all of a sudden, this go down. It means this vertical component will subtract here, and your lift will be this. It means the aircraft will just fall. That's what's happening actually. Now, this is the thunderstorm, but you can also have turbulence because of the high grounds. If you go close to the ground, you're landing, and the wind is strong. Because of the shape of the hills, the movement of the air will be different, and it will have about the same effect. But the basic principle is that actually. Do you have anything new?
Yeah, which is the so-called wind shear. Normally it's happening near to mountain areas where you have a sudden difference in pressure, high pressure and low pressure, which is causing turbulence, and also this phenomenon of changing of the vertical component of the wind.
Thank you. And the last question for tonight is...
In fact, I have a little set of small questions, maybe trivial, for our friend pilot. Sometimes I read on newspapers things like, such as the pilot was ill, and then suddenly somebody from the passengers take the command and land. Or other things such as there is a bunch of kids pointing lasers on planes and disturbing the pilots and things like that. And there are plenty of things like that in the net. Now, the question is that there is something true there, or it's just legends that are pumped, or something like that?
Okay, first question. Yes, everybody can become ill. We call that pilot incapacitation. And when you are training as a pilot, and we have about an average of 1 hour of flight simulator per 10 hours of flight. That's a lot, huh? I mean, in our company at least. And we train sometimes an incapacitated pilot. We have in the cockpit a way of detecting that. We have a standardized way of talking. I'm saying something, he's replying. Okay, I'd say flap 15, I say okay, flap 15 selected, flap set. And by talking, especially on takeoff, is looking at the speed, and I'm flying outside. If I'm taking off myself, I'm looking outside and he's reading the speed. There is a speed which is called V1, it is a decision speed. You say before that you stop, after that you go, continue. And also before that there is, you say 6, 17 knots, 18 knots, you say something. If the guy doesn't say anything, you say it once, twice, and then you stop, or you do something. So it's a way of, it could be obvious, the guy is just falling, punch, on the controls. But it can be very subtle. The guy starts to be, problem is he starting a stroke? It can happen. I mean, we can fly up to 65, so if there is a stroke, he's not very, or didn't feeling very well. I was flying with a guy a couple of years ago. He was starting a kidney stone. He didn't tell me anything about it. And then just during the departure, he said, wow. He didn't say anything, but he was really in pain. He said, how are you? And the way he was telling was something lying on the side. So that's probably the kidney stone. We just cancelled the flight, went for land with the emergency services, and it was indeed a kidney stone. But we are able to fly by ourselves, and actually, as fighter pilots, we enjoy doing so. But yes. But I mean, when I'm flying as a passenger, because I'm flying every week, at least twice a week as a passenger, they know that we are crew members, because on our passenger boarding pass or on the ticket, they know there is a pilot there, and if there is a need, we are there. I mean, I used to say in the beginning, because I was flying on an aircraft type, I was type rated. It means I was legally able to fly with it. And I used to say to the cabin attendant, say, oh, by the way, if things happen, I'm type rated on this aircraft. And I was so pissed, because they looked at me like, who is this guy? Who do you think it is? He's like, no, I'm Mr. Pilot. I was, no, I mean, in no way trying to be, no, just saying back, if something happened, I'm here, just in case. So, the second one was about laser. But laser, it's true. It can laser is a very, very strange form of light that can, I mean, it's used to cut your eyes. When you have a surgery, they use laser. So you can be really severely and definitely injured by a laser beam. That's why every time there is a laser somewhere, we know where there are lasers. Yeah. I mean, not all lasers are eye safe.
So those are not lasers.
I mean, no, yeah, you can be injured, but most of them are eye safe. I mean, the one we use currently to show on the board, something like that, it's eye safe. I'm talking too much.
Well, I think we have to close this very interesting session now. It's already 20 minutes after the expected time. And I hope you enjoyed this session. This was the first of our series of Brussels Science Apéro. We are going to have 2 other sessions in the pipeline. One, as you might have seen from our postcards. The next one will be on the 29th of May, about pesticides, what we eat usually in our dishes, in our meals. And the third one will be on the 19th of June.
Excuse me, Inano. I don't know if some of you have seen the dress, because it's very small, but we can see planes, little small planes. So I'm wondering if for the next time you will have a dress with pesticides.
Surprise, we'll see.
Sorry.
Can bring one under formalin. We'll see. And the third one will be about brain. I don't know. Now we can cut the head. And it will be about the factors influencing our mood on the 19th of June. I hope you will join us also for the other sessions. And then starting from September, we are also launching new sessions about new topics. If you have any ideas, because these sessions are helpful for everyone, so if you have any ideas, any suggestions, and you would like to propose any topic, just feel free, and we welcome any suggestions, any ideas. And one last thing, we are going to collect your email addresses if you wish to be informed about the next sessions and keep up to date. Our colleagues, you will recognize the Minerva team from the stickers. We have Simona here with an iPad and Irene on the back with a Samsung tablet, just to be politically correct. And you can leave your email address or also your business cards if you have to the other members of the team. And we have also cupcakes at the end of the room made by our colleague Tuce, so you can also have something to eat now. Maybe you are very hungry after all this session. I would like to thank very much our speakers.
Maybe we can applause them.
If you have other questions now, it's networking time, we can hustle the speakers.
They are kidnapped.
Thank you all for coming.
Thank you very much.
Joining us.
Now it's apéro time. Who goes on?